Alright, so this is a video I've been wanting to make for a while. I know a lot of people who'll be doing research on how to have a fridge in a van. A lot of the time what people recommend is to have a DC fridge, a 12 volt fridge, or 24 if that's your system. Because when you have an inverter going from a low voltage to a household voltage, 240 volts or 110 for the Americans, you have a lot of losses, and a lot of losses as well just in the inverter being turned on. If you have an inverter turned on all day, I know that mine is a 2000 watt peak inverter, 1600 continuous. It uses 20 watts. If you're taking nothing from it, it's just burning 20 watts doing nothing in transformer losses. Although mine might be a high frequency one, but it's still not an efficient system. But what I've done in my van is I actually have a household fridge. This is a normal 240 volt fridge. The reason for that is because these are cheap, much cheaper than DC fridges. I know Waco is a very popular DC fridge brand. They're like £800 or something like that. You know, more than $600, I think, in the cheapest case. This is like, I think it's less than £200. It's one of the most efficient ones I could find. So there's a lot of points to consider, especially when you're choosing a fridge. So for one like this, people tend to get a little bit carried away with the efficiency rating, as you should, but you don't want to be looking at the A+, A++. Obviously I'm talking to Europeans here, where we have the EU energy ratings. You want to pay attention to kilowatt hours used per year, because you could have a slightly larger fridge than this, that is, you know, A++, but it actually uses more energy than this one, which is A++, for example. It's all a little bit confusing, but the number you really want to pay attention to is kilowatt hours used per year. And you can divide that by 365, and you can tell you how many kilowatt hours per day, and hopefully it'll be less than one. And then that'll make it pretty possible, even with solar and a little bit of engine charging occasionally. So the way to do it is you need to have the inverter only turn on when you need it, and the way to do that is with a thermostat. So I'm just doing a bit of the test wiring. I've got this little fridge thermostat. Yeah, they're quite popular. I've seen these around a bit. STC 1000. So you set the temperature, you set the swing temperature, so how much you want it to let it go up before it kicks on, and you can also set a compressor delay timer to help protect the compressor, to stop it running too often, turning on and off and on and off. Yeah, it should work out pretty good. As you can see, I've had the fridge off for a while, so the temperature's climbing. Normally I think they're about 4, but I'll have to Google that. So what you do, you have this. It comes with a wiring diagram for those that aren't really into electronics. Basically, you need this to turn the inverter on and off. So on this, I've got the cable from the little relay switch inside here. It's just temporary, it's going around here. It'll go behind the shower eventually. And then into here. This is the on-off switch for the inverter. So all I've done is taken the front panel off, cut the two little cables from that. That leads to these other two little cables. And all I'm going to do is take the switch from the thermostat and just connect it to those two cables in parallel with the original switch. So that means if I turn this switch on, the inverter's on forever. If I turn it off, the inverter's only on when the fridge turns it on. Also, I'm going to put some other kind of isolation in, so that you don't end up somebody works on the electrics and then the inverter turns on and zaps them. It's like a perfect set trap. But by doing it this way, I mean, you're still getting some inverter losses. Not too bad on this one, because I have a 48 volt inverter, so it's a little bit better. I think it's 95%, but I would give it 90 probably, realistically, under low load. So you're losing 10% there, but this fridge uses less than 200 watt hours per day, which is not a lot, and it didn't cost £800 like one of the DC ones did. So it's kind of better to save your money, get a better inverter, save money on the fridge, and even if it is a tiny bit less theoretically efficient, I feel like you're gaining something in being able to, if this breaks, I can just buy a normal fridge in a normal shop instead of needing some really niche marine refrigeration thing. So that's the basics of it. I'm going to continue on with it a little bit more. You can see the little cool light is on. So obviously if it was connected, it would be turning the fridge to run at this point. I'll finish off the test wiring and get it wired in properly, see if we can get it working. I'm not too sure if this long cable run from the relay, I think that might confuse the inverter because it's expecting this tiny little cable, but we'll have to see how it reacts. Alright, I'll get back to you when I've done a bit more. Okay, so I've got a very temporary setup here, just to see if it's working okay. Put the LED back. So this is the cables coming from the new thermostat. They run in just through some of the grills, the cooling grills, attached to the original switch cables. Then over on here, I've just turned it on. You can see that the flashing LED on cooling means that it's still in its compressor delay timer. I'll turn that down to 1 minute just for testing. I'll probably put it up to at least 5. It's just because it's bad for the compressor to be turning on and off every 60 seconds. It'd be not good for it. It would be trying to maintain the temperature just too much. It would also be quite inefficient as well. I might even turn it up. It goes up to 10 minutes maximum. So there you go. It's come out of its timer. You heard the inverter beep. The inverter's on, and now the fridge is running. So obviously it'll take a bit of time for the temperature to start dropping. I've just had the door open so you can see. And there you go. We lost 0.1 of a degree. So yeah, so far it's working good, but now I've just got to do it nicely with all the cables packed away in the proper way. And I also need to just wire up the little original switch on the inverter so that I can have permanent on power as well. But yeah, other than that, working well. Alright, so just to demonstrate a little bit more of what I'm talking about with some actual numbers, this is my fridge. It's a 62 litre fridge made by Electric. It's an A+ efficiency, but if we go down to the number that matters, 106 kilowatt hours per year. So if we bring up the calculator, 106 divide 365, so that's 290 watt hours per day per 24-hour period for 62 litres. And this fridge is less than £200. Okay, let's move on to the DC fridge. So this is a very popular brand I've seen around a lot. They do look very nice fridges. This one's actually pretty cheap. Well, it's not cheap, but it's cheap for how expensive they normally are. They're normally more than 700. So yeah, this is 65 litres, I believe. It's 57 litres plus a 7 litre freezer. Alright, so this is DC, doesn't require an inverter or anything. Let's bring back the calculator. So here we see it's 1.14 amp hours per hour. So I don't know what voltage they're assuming there. I would assume it's 12.6. Well, let's be generous and say that it's 12. 12 volts times 1.14. It's using 13.68 watt hours per hour times 24. You have 328 watt hours per 24-hour period. So as you can see, like the reason that the AC fridge is actually a little bit more efficient is because every fridge in every person's house is an AC fridge. There's been a lot of time for the industry to really optimize compressor technology, and I think that's the reason you can get such efficient compressors so cheap. Whereas a DC compressor is something that's like a little bit niche, and it's not really that widely used in the normal real world. So you can see this fridge actually uses more power and costs 3 times as much. So I mean, it's just something to think about. I mean, it's a lot of money for a lot of people, I know, but it seems like some people on these van builds seem to have like an unlimited stream of money from somewhere. So if you've got the money, go for it. But if you haven't, another option is to try an AC fridge.